would you be able to pick somebody up from campus? There was a shooting at UNC Chapel Hill. I have somebody that I know there. So I don't know if I'd be able to go near campus or not.
I have no
I do
idea.
not
I
think
think they
so.
generally lock it down, don't they?
I
Yeah.
would think so too.
There was in the spring, there was rumors of a shooting. No, there was somebody shot himself in the foot, but they didn't know that initially.
Right.
Yeah, it was one of the
Yeah.
high school students on a tour or something. But
Yeah.
yeah, as far as I know, when that happens, they pretty much make it so that no one comes onto campus and anyone getting off campus has to like show their ID and everything.
Right.
I can't imagine they'd let you on.
Right, okay. Okay, I just wanted to clarify.
But just to make it official, I'm not law enforcement. I don't make those decisions.
Yeah.
But that seems to make sense to me.
Mm.
All right, I was listening the other day to the radio and someone was talking about, school shooting drills. And the gentleman was older than I was, but he talked about the duck and cover. Are you familiar with the duck and cover?
Yeah, the nuclear bomb.
Yeah. They had stopped doing it by the time I was in school, but I'm not quite sure which one's scarier. Obviously, in retrospect, we were never under a nuclear attack, but anyway, have your thoughts.
Sorry.
No, not a problem. I guess you don't know whether the person's okay
They
or
said
not?
that they're hiding right now, so the shooter was supposedly in the building next to them, so,
Do you need to call somebody or?
I don't think so.
Okay.
I don't know who I would be able to call,
Okay.
and I don't wanna disrupt, or like,
If you need to dash out at some point because something changes, I'll
okay.
assume it has something to do with that. All right, let's change the problem around a little bit. Yeah. Start fresh. I hope that you would recognize that if I said the ball is thrown up, I'm assuming that you're picturing it being tossed upwards and not vomited. So, just in case. I'll also give you another image in your head. But the ball is thrown upwards initially at a speed of 40 meters per second. How far up will the ball travel? I do need to give one other piece of information, although you might assume it already. From near the surface of the Earth. All right. Again, if we know three things, we can find the other two. So let's put them down. We got delta x, or s or r, whatever letter you happen to be using. V initial, v final, acceleration, and time. All right, so what do we know?
The initial 40 meters per second.
And you're good with that? All right.
Like acceleration too, don't we?
What is it?
The 9.8 meters per second squared, assuming it's gravity, assuming we're on Earth.
That's what you said?
Negative.
Why negative? And,
Opposite way of the initial.
all right. Now, so why is this negative though? Why is down negative?
Well, up is positive.
Why are we saying up is positive?
I guess it's arbitrary.
Well, in this particular case, whom do we have to blame for making up positive? No. No, don't go pointing the finger at me. Benjamin?
The question, Joe.
As soon as he said 40 meters per second here, and I said, are you good with that? And he said, yes. He established up as positive. At that point right there, up became positive. If he had said negative, that's fine too, then up is negative, or down is positive, however you wanna look at it. So, once that first number is set, we've established our convention, and so let's go ahead and write that, up is positive. Thereby, the acceleration of gravity, which is downwards, has to become negative. These are opposite signs, which, however you play it. All right, we've got one other piece of information that is implied.
Oh, that the final velocity would be 0.
Absolutely, there we go. Now, there is one assumption that I did not state, but a common thing, ignore air resistance. All right, so what are we trying to find?
The total time it takes for it to come to the ground.
Where in the question does they can tell you to do that?
T.
I mean, we
Oh.
could find T, I'm not saying we can't find it, but.
Oh, sorry, I was looking at the chart. How far it's going to travel upwards before the acceleration counteracts its initial velocity.
Okay, so we could find time first up to that point, not for the entire trip, but for up to the peak, and then plug in, we have other equations to plug into, or we could, if we're solving for this and we don't know time, which equation would you use?
Fourth one.
All right. 0 squared is equal to 40 squared plus 2 times negative 9.8 times displacement. Technically, if we're using, it's a dot product over there, acceleration is down, displacement is up, so really, technically it's negative of 9.8 times that of the magnitudes. That notation is absolutely horrible. So I'm just gonna go back to what I had before. And so we have negative 1600 is equal to negative 19.6 delta x. And somewhere around 80, a little bit above 80 meters.
81.6.
81.6? Is that what you said?
Yeah.
All right, meters. All right. Now, how much time does it take to get to the top? Which equation would you use?
Second one.
All right, so you got 81.6 is equal to 0 plus 40 divided by 2 times time. And so T is equal to 81.6 divided by 20, which is 4.001.
001. Or 002. You want to be a little bit more accurate.
Units.
Seconds.
Yep. All right. Questions here before I make it more perplexing potentially? All right, everyone's got a calculator. Let's see, also upwards, initial speed, just change that number. So we're developing a collection over there. All right, assume that, you know, you're standing over a cliff and you throw the ball up so that it can get to 40 meters below. Same type process. It's already written here and I don't feel like erasing it. Let's just go ahead and make up positive. So, what do we know?
Initial velocity is 30 meters per second.
Okay.
I'm so sorry for the disruption.
No.
Sorry, guys.
No,
Good
you're
luck.
fine.
Thank you.
Final velocity is 0.
Nope.
Oh.
We're not at peak here. It's three different questions. So for the first question,
I guess acceleration is still due to gravity.
yeah, I still have it above Earth, so negative 9.8 meters per second squared. Now, I have some students who really like using 9.81 because they feel it's more official. First off, in lab, never, ever use 9.81. I didn't talk about why the acceleration, why I know it's 9.798 meters per second squared.
No,
But we haven't had a lab that actually deals with that yet. There are gravimetric experiments that have been done all over the country, at this point all over the world. But we're fortunate in that you've got Silas Creek here and, is it Miller? The one that's right over here, is that Miller or Ebert? It's Miller, I think. And then Ebert?
Yeah.
All right, so we got Miller that crosses over Silas Creek. If you're coming from school and there's Ardmore over here, you take a Ardmore district, housing area, whatever the district is, not Ardmore building, but
Yeah.
you take a right, there's a road that tees right into Silas Creek. It's the next one over, there's the one that tees right into it. Right at that median, there was one of the gravimetric studies that was done. So we probably better than almost any other school in the world, unless they've done experiments at the schools themselves. But we were fortunate enough that the experiment was done right out there, about second story high. You can also interpolate from some of the aviation data they've done, and you come out to the same answer. Because at this point, they've basically done gravimetric studies in grids around the entire world. All right, so anyway,
Displacement would be negative 100.
how'd you get negative 100? We're doing this one right here?
Sorry, positive 100.
All right, where'd you get your 100?
The last value that we're interested in is when it's 100 meters above.
50 meters above?
100 meters above.
That's the third problem. These are three different questions.
Oh, sorry.
A, B, C.
Positive 50.
Okay. Yes, it'd be positive 100 when we get to the last one. So positive 50 meters. All right, we're trying to find time. Yeah, so which equation should we use?
Second one.
Second one? We don't know VF and we don't know time, so that gives us two unknowns.
Third one.
All right, VF's not in it, we're good to go. All right, it becomes almost a plug and chug. Well, it is plug and chug, just chugging takes a little bit more. So I get 50 equals 30t minus 4.9t squared. Now, I did skip a step there, it's 1/2 times the acceleration, and so that's where the 4.9 comes from. How do we solve it? Or how will you solve it?
We can put the 50 on the right and use the quadratic equation.
Ooh, let's work on the semantics there. This is a quadratic equation.
I mean, the quadratic formula.
Yeah, there we go. All right, so we have 0 is equal to, I'm gonna put it in descending polynomial order, plus 30t minus 50. All right. Quadratic formula?
You mean like the whole, well, I guess negative 30 plus or minus the square root of 30 squared minus 4 times negative 4.9 times negative 50 over 2 times negative 4.9.
There are two answers. And if you're shaky on what the quadratic formula is, that it's given, or if I didn't give it to you, you can just ask.
Well, it's complex, so
What's the determinant?
Negative 3.0212. Sorry, 0.6122.
Sorry. Negative 3.0.
0.6122. Because the rest of it's just an unreal number.
Okay. Let's change the problem then. Let's make it 40. With changes. Oh, well, actually, while we're still on 50. What does a complex time mean?
it means it can't happen, right?
Or
Something else is wrong.
discriminant, that's the word I meant to say earlier. Yes, that's absolutely. Do not see a negative under the radical and go, you know what, let's just get rid of the negative sign just because it's inconvenient. Sometimes you get lucky and it works. Sometimes you miss the point of the problem. All right, so if the discriminant is negative or you get a complex answer, then the problem can't be done. So if we change it to 40 meters above, so that becomes 40 That's 40. That's 40. That's 40.
Like just take a moment to think, I would have recognized that. Probably wasn't gonna work.
Either negative 31.1 or negative 28.9.
Did you forget to divide by?
No, doesn't seem
Yeah, I am not buying that.
I have 1.96.
You got what?
1.96, and I haven't got the other one yet. And 4.160.
4.160.
Anyone else get the same thing? All right, we got one person backing you up.
I just got it again, so. thank
And you back up yourself, okay. See, Will and Benjamin typing away on the calculator, so waiting for one of them to back it up.
Can't quite read it, what's the last thing there?
This right here,
Yeah.
negative 40.
Negative. I got the 1.96 and 4.16 as well.
All right,